Alright, we're going to take a look at the resample operator, which is part of the spawn group of operators, and it has two modes. It can either interpolate or it can optimize. Now, because it's a spawn operator, we get into this little siblings, parent, child, first child, last child, and I've covered in a separate video, but it pays, or it's worth to revisit here, because we can also discuss how we can use this display data. Right, so in this instance, we can see we birthed a cube. It's the parent because it spawns some children. In this case, it spawns 3 children, and they're orange in color, and I've represented all that data over here. So revisiting everything here, we can kind of go, okay, the parent spawned these 3 children. So these 3 particles are children of this parent. This parent is the parent of these 3 particles. And we delete that from it. Children of a particle, when there's multiple of them, are siblings to each other. So these 3 spawn particles are siblings to each other, and there's a first child and there's a last child. So we can visualize some of this information by turning on the display data, and we can use show parent and we can use the show sibling data. Now, every particle has a unique ID. There can be no 2 particles with the same ID, period. Right? All particles have a unique ID. So if we use my little program here to zoom in on this section, and we zoom it in a bit, we can see that this particle here is ID 2, and we verify that with the display data. And we can see that ID 2 appears in this sibling section of the information. And so this middle number here represents the ID of that sibling, right? And then the information on the left is its previous sibling, and the information on the right is its next sibling. So in this case, this is the middle child. It happens there's only 3, so if we had 5, 6, or 7, there could be quite a few particles or siblings in between the first and last. So now if we look at this next piece of data, and we go to, on all of them we can see that the parent is 0. And because there's only a unique ID for every particle, this is the parent, and you can see it has an ID of 0. You can also see that when we show parent sibling information here, we get a -1, but we'll come back to that. Anywhere where you see -1, and Tyson's a programmer, so -1 is kind of like a programming thing, but it actually can be interpreted that there is no previous sibling. So when we look at this information here, right, there is no previous sibling. This spawn particle is ID 1, and the next sibling is 2. So if we look at this, because there's no previous sibling, this would actually be the first child. Right? And when we look at the last one here of the 3, we can see that the -1 is now at the right. So the ID of this spawn particle is 3, its previous sibling is 2, there is no next sibling, so that means this is actually the last child. So from that information we've gathered what is the first child, last child, siblings, and all that. Now you can spawn and spawn again, right? So you can actually have a hierarchy of spawned particles. So when we look at this parent one, and we see all this minus stuff, well, wherever you see the minus stuff means there is no parent to this particle, and it has no siblings, period. and the middle number again is just its ID. So what we firmly established here is that spawning, which means creating particles from existing particles, creates children, and the particle that spawned them becomes the parent. The children become siblings to each other, and we can have a first and last child. And when we see things like closed sibling loops, connect first and last, etc., that's where all that comes from. So I hope that kind of helps you how to visualize display data in relation to family relationships and spawned particles, and also how to cipher them using this display data. And I also hope it helps explain this whole parent, child, sibling, first child, last child relationship. We'll just keep it at that, and have a good one.